Hello everyone and welcome back. So in this video I want to do a quick walkthrough of the curriculum and talk about what to expect from this course. This course explains the concepts from basic to advanced, so it's advisable not to miss any section before going to the next section. The very first section is introductory section, in which I explain the basic contents such as what is algorithm, what is data structure and why we need them. And the next section is called recursion, which is a really important stuff, and this is used in many algorithms. So it's very important to learn it before diving into deep data structures and algorithms, because it comes up late on in many of our algorithms. So there are lots of interview questions about recursion, and the main ones are explained in cracking recursion interview question section, which is our next section. Then the next topic is big O notation. It's a way of describing and talking about the performance of efficiency of code. So we use this section all the time, so definitely do not skip that. And here also there are many interview questions related to Big O. So the most asked questions are explained here in the section of cracking Big O interview questions. Then we move on to the next section, which is called arrays, in which we have explained different types of arrays such as one-dimensional array and two-dimensional arrays. And we have introduced how they are represented in memory and time and space complexity for array operations. And here again, we have discussed the most asked interview questions in the section of cracking array interview questions section. Next, we shift over to talk about linked list, which is the longest section of this course. Here, we have covered all details of linked list with performing all operations on different types of linked list, such as single linked list, circle single linked list, double linked list, and circle double linked list. You will never find such detailed information on any other course on the internet about the linked list. Additionally, we have explained famous interview questions about linked list in separate section. Then we move on to two more additional data structures, which are stacks and queues. These are very commonly used data structures. So here also the most common interview questions we have talked about stack and queue over here. Then from here we start another very detailed section which describes whole tree data structures, in which we include binary tree and the main concepts of binary tree such as pre-order traversal, in-order traversal, level order traversal, and post-order traversal. So here again, we recall the things like big O notation and recursion in this section. Then from here, we continue to the binary search tree. And then we are continuing to the AVL tree. And in AVL tree, we have covered important concepts like left-left condition, left-right condition, right-left condition, and right-right condition. Here we have implemented these conditions in inserting and deleting a node from AVL trees. So then we go to the binary heap, which is also related to trees, but here this is the very special case of tree. And we have talked about common operations of binary heap. And finally, we got to the last type of tree, which is trie. Trie takes characters as a node and is very useful, especially when you are developing applications like dictionaries. So we have talked everything about trie in this section. Then from here we move on to the hashing section. So here we have implemented various types of hashing like linear hashing and quadratic hashing. So from here we get to the second section of the course. Up until this point it has been about sort of stepping stones, recursion, big O notation, and different types of data structures that can be used in different types of algorithms. So from this slide until the end of this course we will talk about different types of algorithms which are very essential concepts of computer science. From here, we move on to the sorting algorithms, in which we will learn 7 different types of sorting algorithms. We start with bubble sort, which is often considered the easiest or one of the easiest. Then we move on to the selection sort, then insertion sort, and those three from little group of sorting, intermediate and elementary sorting algorithms. Then we move on to the bucket sort, the merge sort, and then quick sort. And here, these all algorithms involve recursion and big O notation. So here again, it's very important not to skip big O and recursion sections before coming to this section over here. Then we finish up this section with heap sort over here. Then from here, we continue to describe search algorithms like linear search and binaries. Then we continue from here another detailed section which is called graph algorithms. So this is something a lot of people are intimidated by. So here, first we start explain graph data structures, then we show how to implement these graph data structures in Java. Then we continue to implement graph algorithms like breadth first search depth first search in graph traversal. Then from here, we are going to continue another section, which is dynamic programming. I know many people are curious about learning dynamic programming. And here, we will talk about main properties of dynamic programming, such as optimal substructure problem and overlapping subproblems property. Then we will learn two methods of dynamic programming, which is top-down with memoization and bottom-up with tabulation. And I will show you 4 steps to convert divide and conquer algorithm to dynamic programming algorithm. Then we will approach over here. Then after this section, I have created challenging dynamic programming exercises section for those who like pain and misery, because these are very quite hard problems. Then we have created a section which is called a recipe for problem solving, in which you will learn how to solve any given programming problem during the interview process in 5 steps. Then finally, you will reach the Wild West section, which includes coding exercises for all topics that we have explained in this course. So that's where we finish up this course. But this is not the end, because I am in process of recording new sections based on your requirements, and more sections are about to come. I know that this is a very long introductory video, but the course is very detailed, so I tried to form an idea of what you will get in this course. So hopefully you will enjoy the course, so see you in the course.